Hello, my friend. Welcome to my channel. So today I'm going to solve a problem related to hypothesized testing for population mean mu when the population standard deviation is unknown. So here, this is the example. A medical investigation claims that the average number of infections per week at a hospital in Pennsylvania is 16.3. A random sample of 10 weeks had a mean number of 17.7 infections. The sample standard deviation is 1.8. Is there enough evidence to reject the claim at alpha equals 0.05? As you can see, here is the claim. The claims that the average number of infections per week at a hospital in Pennsylvania is 16.3. As you can see, when you write down the null and the alternative hypothesizes, here the mean population mean equals 16.3 is the null, and the other one, the alternative one in this case, is not equal because it claims that the average number of infections is 16.3. In this case, the null hypothesis is the claim, and the alternative one is not equal case. So as you can see, since this is not equal case, this is two-tailed test. Let's see all the informations here. A random sample of 10 weeks. The sample size is 10. And sample mean X bar equals 17.7. And we have the sample standard deviation. The notation is simple S equals 1.8. So as you can see here, sigma is unknown. The population standard deviation is unknown, so we are going to use t-test. So we use t-scores. Okay, let's find the test statistic. Test statistics. T naught equals, the formula is x bar minus mu over S over square root n. So x bar is 17.7 minus mu is the hypothesized value, which is 16.3 over sample standard deviation is 1.8 divided by sample size is 10 and square root. So the value of this number is 2.46. So this is the test statistic value. So in this problem, I'm going to use critical value method and p-value method. So let's look at the critical value method. Here, the critical value method, the alpha value is given, which is 0.05. Since this is two-tailed test, we need to find one-tail area. Since the alpha is 0.05, then alpha over 2 is 0.05 divided by 2, which is 0.025. So then this one-tail area is 0.025. This one also 0.025. Now we need two cutoff points over here. One is negative and the other one is positive. So two critical values. To find that, you need to look at the t-table. To use the t-table, you know we need degrees of freedom. Degrees of freedom is sample size minus 1. Sample size is here 10. 10 minus 1 is 9. So the degrees of freedom is 9. So you look at the 9. Degrees of freedom represent the first column. So go to 9. And then, as you can see here, one tail, you can look at over here, one tail 0.025. Then you will see the number over here is 2.262. So this is the positive value. So the positive critical value is 2.262. The other one is negative 2.262. So you have two critical values here. One is negative 2.262. The other one is positive 2.262. So this region is your critical region, and this region also critical region. So this area is your non-critical region. Okay, let's look at the p-value here. P-value is the probability that your test statistic or the sample statistics is extreme when the null hypothesis is true. So here, probability t less than, let's take 2.46, your test statistic value. So here we have to use the t-table. So you need to find the two values that 2.46 falls between. So let's look at the t-table. Degrees of freedom, 9. And you have to look at two values that 2.46 falls between. So you will see those two values are 2.262 and 2.821. So then you have to look at the alpha values corresponds to these two values under two-tailed test. Under two-tailed, look at the values here. You will see those two values are 0.05 and the other one is 0.02. So that means your p-value is between 0.02 and 0.05. So we can have a range for the p-value in this case. We cannot find the exact p-value for this test, but we can have this range. And now let's make the decision of this problem. According to the critical value, you have to look at your test statistic value 2.46. As you can see, 2.46 falls over here because 2.46 greater than 2.262. So your test statistic value falls in the critical region. So that means you reject the null, which is H0. And under p-value, so you compare your alpha value, which is 0.05. You compare this one with p-value. As you can see, your p-value is between 0.02 and 0.05. You can see that p-value is less than 0.05, which is alpha. So if your p-value is less than your alpha value, then you reject the null, H0. So the conclusion you can write down here, there is enough evidence to reject the claim that the average number of infections is 16.3. So here we write down our conclusion like this because our claim is the null hypothesis. So that's why we write down there is enough evidence to reject the claim that the average number of infections is 16.3. So that's how we use the t-test to make the decision of this kind of a hypothesis testing. So I hope you understand this one. If you have any doubts or concerns, please comment. And thank you so much for watching this video. If you want to see more videos like this, please subscribe to my channel. Bye.